Gravity, that elusive concept to which we grant hardly a thought. Without it, we would simply float away. It is what keeps us, as well as everything around us, together in one piece. Everything has a gravitational force. The Earth, the Moon, and even this ant all have gravitational fields and are affected by gravity. The strongest force is exerted on the objects closest to the center of gravity. Therefore, gravity is more powerful on Earth's surface than in Earth's high atmosphere, because down here, we're much nearer to the core of the Earth, which is the center of gravity.
Newton's law of universal gravitation. Every point mass attracts every single other point mass by a force pointing along the line intersecting both points. The force is proportional to the product of the two masses and inversely proportional to the square of the distance between them. The equation for the law is this. Force equals the gravitational constant times the first mass multiplied by the second mass divided by the distance between the centers of the objects squared.
Yeah, so basically, this means that every object in the universe has an effect on all the other objects around it.
Since every object with a mass has a gravitational field, you might find yourself in a situation where you have to calculate the gravitational field. It can be found using this formula. Now, we have to calculate the gravitational force between a cat and this sonic screwdriver that are 1.5 meters apart. The formula for gravitational force is the gravitational constant times the mass of the first object multiplied by the mass of the second object divided by the distance between the centers of the two objects squared. First, we need to know the mass of each object. For the cat, I weigh myself once with and once without the cat, and then calculate the difference, which is 9.5 pounds. This is equal to about 4.08 kilograms. The sonic screwdriver weighs 72.6 grams, which is 0.0726 kilograms. The distance between the objects is 1.5 meters. The universal gravitational constant is 6.67 times 10 to the negative 11. So, we multiply everything by the gravitational constant times the mass of the cat in kilograms multiplied by the mass of the sonic screwdriver in kilograms divided by the 1.5 meters between the objects squared. It seems as though the gravitational force between the cat and the sonic screwdriver is 8.78 times 10 to the negative 12. The ocean, which covers 70% of the Earth's surface, relies on our little satellite for the tidal cycle. In most seaside places across the globe, the tide rises and falls around 4 times every day. We conducted a little experiment to show just how the moon dictates the motion of the ocean. For this experiment, you'll need to fill a bucket with water. How much depends on how brave you are. Here, we put green food coloring in the water so that you can see it better. You'll probably want to do this outside. So, once you have your ominous water-filled bucket and your Gabe, stand somewhere clear of any obstacles and start swinging. Once you get the momentum going a bit, you'll be able to actually swing the bucket right over your head. Don't worry, it's practically impossible for this to go wrong. Believe me, we tried. Anyway, this experiment demonstrates the moon's effect on the tides. If you imagine that your arm is the Earth, and the bucket is the ocean, and that the bottom of the bucket is the moon, you'll notice that the ocean is being pulled towards the moon at all times throughout the Earth's rotation.
Because of the spinning effect of the Earth, and with the right speed and altitude, objects in proximity of the Earth or other large masses do not fall towards the center of gravity of the Earth, but instead are caught in orbit and can be said to fall around the Earth. We can find the speed of a satellite orbiting Earth by using this formula. A satellite's orbital period is the amount of time that it takes for an object to go around a mass, such as the amount of time that it takes for the Earth to go around the Sun. Of course, these equations can be used for any object in orbit around another. The period can be found by using this equation. Inertial mass determines how a single object is affected by others.
Gravitational mass establishes how 2 or more objects affect each other. For example, when I push Gabe in a rolling chair along a flat surface, he is moving relative to the chair. His inertial mass is a measure of how he, as an object, can resist the force of me pushing him forward. Inertial mass is equal to the net force exerted on the object that's me, divided by the acceleration of the object. To demonstrate gravitational mass, I have to push Gabe up a hill. The reason that I have to work much harder to push him now is because gravity wants the chair to roll back down the incline. So, the force that I am working against is not Gabe's weight, but the force of gravity. Gravitational mass is equal to the distance between the objects squared times the gravitational force divided by the gravitational constant multiplied by the other object's mass.
Larger masses such as the Sun and other stars are also capable of deflecting light. When light passes a mass with a stronger gravitational field, the light changes its path. This means that we are able to see stars that are actually on the other side of the Sun, because as the light comes close, the gravitation field attracts the light, forcing it to curve. Gravity is all around us, and though we often do not acknowledge it, it is what keeps us alive. Without a gravitational force, nothing would hold together. Without it, nothing would exist.